Our objective in this lesson is to use appropriate graphs to represent organized data. We are going to discuss histogram, frequency polygon, and ogive. Previously, you have learned how to construct frequency distribution table. Today, you will learn how to present this graphically. You also learn how to construct bar graph. We will be discussing another kind of bar graph today, the histogram. A histogram is a kind of bar graph. It displays frequencies of class intervals using vertical bars. So what then is the difference of histogram and bar graph? For one, there is no gap between bars and histograms. You might wonder why. Because histograms are used to display continuous data. Continuous data are data with continuous measures like height, weight, temperature, and the like. I have a video lesson on this for your reference. Histograms are for quantitative data, while bar graphs are for categorical data. Histograms are used to show the shape of the distribution, while bar graphs only compare variables. Here are the steps in constructing histogram. I will discuss this in detail using an example. Below is the frequency distribution table of 30 students and their summative test in mathematics. Construct a histogram. First step, create and label the x and y axis. Here is the x-axis and the y-axis. The x-axis is for the class intervals. Give it a name such as height, weight, scores, and the like. Since we are talking about scores in a summative test, then the name of my x-axis is scores. The y-axis is for the frequency or relative frequency. In this video lesson, I am going to use frequency. Step 2. Mark the y-axis with the frequencies. Observe equal distances between them. My least frequency is 3 and the greatest is 7. They are close to one another. I decide that the interval is by 1 unit. The intersection of y and x-axis is 0. With an interval of 1 unit, the next value is 1. And then 2, 3, 4, 5, 6, 7. Make it a habit to add the next value. This is for the aesthetic appearance of our graph. Step 3. Mark the x-axis with class boundaries or class marks. Observe equal distances. In this particular example, I am going to use class boundaries. Our first boundary is from 17.5 to 26.5. And then 26.5 to 35.5, 35.5 to 44.5, 44.5 to 53.5, 53.5 to 62.5, and 62.5 to 71.5. Step 4. Construct the vertical bars corresponding to their frequencies. For our first class, our frequency is 6, so here, 6 up to here. And then the next one, our frequency is 5, and then 4, and then 5, and then 7, and then 3. Notice that there are no gaps in between bars. Again, because histogram is used to display continuous data. Step 5. Draw a zigzag line between the y-axis and the first rectangle to represent the gap from 0 to the first lower class boundary. Here it is. Step 6 is optional. You may write a title for the histogram. If I were to write a title in this histogram, it would be Results of Summative Test in Mathematics. Another way of representing frequency distribution aside from histogram is the frequency polygon. It is a kind of line graph that represents data. It is a graph formed by using line segments to connect the class marks or midpoints of each class interval plotted against their corresponding frequencies. It is usually drawn from a histogram, but can be drawn even without the histogram. It is used to depict the shape of the data as well as its trend. Here are the steps in constructing frequency polygon. I've said earlier that a frequency polygon is usually drawn from a histogram. That is what I am going to show you first. Here is the histogram that we constructed earlier. Now, to create a frequency polygon, the first step is to determine the midpoints of these bars. So for this bar, the midpoint is in here. This one here, here, and here. Then, let us connect these points using line segments. 1, 2, 3, 4, and 5. We all know that a polygon is a closed figure. In order to close this, we are going to add interval on both ends of our distribution. To do that, simply determine the difference of the class boundaries. The difference of 62.5 and 53.5 is 9. In fact, the difference of all lower class boundaries and upper class boundaries is 9. So we just have to subtract 9 from 17.5. 17.5 minus 9 is 8.5. So the interval here would be 8.5 to 17.5. In here, instead of subtracting, we're going to add 9 to 71.5. 71.5 plus 9 is 80.5. So the interval here is 71.5 to 80.5. Now, for the frequency of additional intervals, that is equal to 0. So we're going to get the midpoint of this interval as well as this one. To close, let us use line segment also here. Now, we have our frequency polygon. To show better, I will remove the histogram at the back. This time, I am going to show you how to construct frequency polygon without the histogram. Same steps. First one, create and label the X and Y axis. X-axis, Y-axis. The X-axis is for the class marks, or another term, midpoints. Give it a name such as height, weight, scores, and the like. Again, these are scores, so we have scores. The Y-axis is for the frequency. Step 2. Mark the Y-axis with frequencies. Observe equal distances between them. I have decided earlier that the interval is by 1 unit. The intersection of the axis is 0. Interval of 1 unit, the next value is 1. And then 2, 3, 4, 5, 6, 7. Don't forget the additional 1. Next step. Mark the x-axis with the class marks or midpoints. Observe equal distances. So class mark, this column, the first class mark is 22, then 31, 40, 49, 58, and 67. Step 4. Plot the points of the class marks or midpoints against their corresponding frequencies. For the class mark of 22, the frequency is 6. So 22 and then 6. And then we have frequency of 5, 4, 5, 7, and then 3. Step 5. Connect the points using line segments. 1, 2, 3, 4, 5. Step 6. To close the frequency polygon, let us add interval to both ends of our distribution, each with 0 frequency. So the difference of 31 and 22 is 9. Let us subtract 9 from 22. 22 minus 9 is 13. Here, we're going to add 9. 67 plus 9 is 76. The frequency is 0, so we're going to put a point here and also here. Let us close as well as this one. Step 7. Draw a zigzag line between the y-axis and the first class mark to represent their gap. And so we are done with our frequency polygon. The last one is ogive. An ogive is a type of frequency polygon that shows cumulative frequencies. It shows a growing or lessening total. It is used to determine how many numbers lie below or above any particular value in data. It is not ideal for comparing categories. The horizontal axis is for the data values and either cumulative frequencies, cumulative relative frequencies, or cumulative percentage frequencies on the vertical axis. There are two types of ogives, the less than ogive and greater than ogive. For less than ogive, upper class boundaries are plotted on the x-axis and less than cumulative frequencies on the y-axis. For greater than ogive, lower class boundaries are plotted on the x-axis and greater than cumulative frequencies on the y-axis. Less than ogive is also known as the rising curve. You can see it here in our picture. And for the greater than ogive, it is also known as the falling curve. Here are the steps in constructing ogive. Let us have an example. In this particular lesson, I am going to construct less than ogive. Step 1, add 2 columns to the frequency distribution table. One for less than cumulative frequency and the other one is for greater than cumulative frequency. Since I am only going to construct less than ogive, I will add only one column and that is for less than cumulative frequency. Now, if it is less than cumulative frequency, you start at the lowest class interval. Here, our lowest class interval is from 18 to 26. The frequency is 6. You just have to copy it here. And then you add the next frequency. 6 plus 5 is equal to 11. We are adding because this is cumulative. 11 plus 4 is 15. 15 plus 5 is 20. 20 plus 7 is 27. 27 plus 3 is 30. You will know that your cumulative frequency is correct if the last value is equal to the total number of observations. Step 2. Create and label the x and y axis. Again, x-axis, y-axis. The x-axis is for the class boundary. Let's give it a name. Again, these are scores. And the y-axis is for the cumulative frequency. To be specific, we are constructing less than ogive, so this is less than cumulative frequency. Step 3. Mark the x-axis with upper class boundaries if less than ogive, or lower class boundaries if greater than ogive. Observe equal distances. We're constructing less than ogive, so we will consider upper class boundaries. The first upper class boundary is 26.5, followed by 35.5, 44.5, 53.5, 62.5, and 71.5. Step 4. Mark the y-axis with less than cumulative frequencies if less than ogive, or greater than cumulative frequencies if greater than ogive. Observe equal distances. Again, we're constructing less than ogive, so we're going to consider less than cumulative frequencies. And we already have it here. So, my least frequency is 6, my greatest is 30. I decide that my interval would be by trees. The intersection of the axis is 0. With an interval of 3, the next value here is 3, and then 6, 9, 12, 15, 18, 21, 24, 27, 30. Don't forget to add additional 1. Next step, plot the upper class boundaries against less than cumulative frequencies if less than ogive, or lower class boundaries against greater than cumulative frequencies if greater than ogive. So for our first upper class boundary, which is 26.5, our frequency is 6. So 26.5, and then here is 6, so here. And then for the next upper class boundary, 35.5, the cumulative frequency is 11, followed by 15, 20, 27, and 30. Step 6, connect the points using line segments. 1, 2, 3, 4, and 5. Step 7, to close the frequency polygon, add boundaries to both ends of the distribution, each with 0 frequency. The difference of 35.5 and 26.5 is 9. 26.5 minus 9 is 17.5. 71.5 plus 9 is 80.5. 0 frequency, so we're going to put a point here as well as here. Now let us close line segment and also here. Step 8, draw a zigzag line between the y-axis and the first class boundary to represent their gap. So we are done with our less than ogive. Now, let us answer these questions. Number 1, how many students are there in all? To answer this question, simply look for the highest point, and that has a cumulative frequency of 30. Let us check. The total number of our observations is 30. Number 2, how many students got lower than 35.5? Here is 35.5. The cumulative frequency here is actually 11. Let us check. 35.5 cumulative frequency is 11. Number 3, how many students got at most 44? So we are going to consider the boundary 44.5 because we want scores that are 44 or lower. The cumulative frequency at 44.5 is 15. Let us check. Here is 44.5. Cumulative frequency is 15. Number 4, how many students got higher than 72? The class boundary to consider is 71.5. Now, higher than. So, do you see any points higher than 71.5? No. So, the answer here is none. Last one, how many students got at least 54? Be careful on this. It says here at least 54. So we're going to consider the boundary 53.5, but at least, meaning the lowest value is 54. So we are looking for this data, not this one. We can easily answer this if we will construct greater than cumulative frequency. But we can also answer this using our less than cumulative frequency. If until 53.5 is here and has a cumulative frequency of 20, let us check. 53.5, the cumulative frequency is 20, and we are not looking for this. We just have to subtract that cumulative frequency from our total cumulative frequency, which is 30. So 30 minus 20 is equal to this portion, and that is 10. Let us check. At least 54, meaning the lowest score is 54. So we will start at this class. On this class, we have 7, and on this class, we have 3. 3 plus 7 is equal to 10. Summary: a histogram is a bar graph that displays frequencies using bars. The frequencies dictate the height of the bars. It is used for continuous data. Hence, there are no spaces between bars. A frequency polygon is a line graph formed by connecting the class marks or midpoints of each interval. The frequencies dictate the height of the points. An ogive is a graph of cumulative frequencies. It answers how many numbers lie below or above any particular value in data. Now, it is time to check your understanding. Pause this video for more time. Let us answer. The histogram below shows the length in inches of hair from the shoulder of female teenagers. Let us answer these questions. Number 1, most female teenagers have their hair length between blank and blank inches below their shoulders. So most, we simply have to look for the highest frequency, and that is 6, and the hair length is between 2 and 4 inches. Number 2, how many female teenagers have hair lengths between 6 and 8 inches? Between 6 and 8 inches, there are 3. Number 3, how many female teenagers were considered in the histogram? So we're going to add the frequencies on each bar. So we have here 4 plus 6 is 10, plus 5 is 15, plus 3 is 18, plus 2 is 20. So we have 20. Number 4, what is the measure of the longest hair from the shoulder? The longest hair length from the shoulder is 10 inches. Last one, which hair length interval has a frequency of 5? Frequency of 5, so that would be from 4 to 6 inches. Gets? Our next lesson is summation.